Welcome to This Explainer. We generally tend to think of science as the ultimate tool for uncovering the true nature of reality, right? But today, we're diving into something completely fascinating and, frankly, kind of alarming. What if the most successful scientific theory in human history literally forces us to abandon reality altogether? That's the exact crazy tension explored in the paper we're breaking down today. Realistic from far, but far from realism. Withering Scientific Realism in the Quantum Case by Raoni W. Arroyo and Christian Durande. To really grasp the gravity of this whole situation, just listen to Richard Feynman. He's arguably one of the most brilliant physicists of the 20th century, and he famously said, "Nobody understands quantum mechanics." I want to use this right off the bat to completely shatter any assumption you might have that scientists have the microscopic world totally figured out. Because, well, they don't. And as we'll see, the problem isn't that our math is bad. Actually, scratch that. It's that our math is almost too good, yet it's completely decoupled from anything making logical sense. Section 1. Shut up and calculate. Okay, let's dive into this. To understand this quantum crisis, we first have to look at the bizarre way quantum mechanics is actually practiced. The math's practically flawless, right? I mean, it built the microchips in your computer, the lasers in your barcode scanners, but its underlying physical reality? Total mystery. The philosopher Tim Maudlin uses this brilliant metaphor, basically describing standard quantum mechanics as just a recipe. When physics students ask their professors what the math actually means in the real world, they're famously met with the canonical response, "Shut up and calculate." The math is just an effective technique for making predictions. It entirely lacks a physical theory to explain what's actually there when we aren't looking. And this brings us to the central inciting incident of this whole debate, the measurement problem. See, the math says systems exist in a superposition of many possibilities all at once, but when a scientist actually measures the system in a lab, they only ever see one single outcome. So how does nature just jump or collapse from many possibilities down to just one? The math alone absolutely does not explain this jump. It just accepts that it happens. And because physicists basically handed this massive black box over to the philosophers, it triggers the great philosophical duel of our time. Section 2. Realism versus anti-realism. Right, so we have these two highly polarized camps with completely different goals. On one side, we have scientific realism. Realists desperately want to know the true furniture of the world, so to speak. They firmly believe the ultimate aim of science is to give a literally true account of reality. But on the flip side, we have anti-realism. Anti-realists argue that the only goal of science is empirical adequacy. Basically, as long as the theory correctly predicts the results of our experiments, who cares about a deeper reality? And this brilliantly illustrates the divide. The philosopher Samir Okasha points out that, for an anti-realist, if the math achieves perfect empirical adequacy, asking whether it truly describes the world is completely redundant. It's just a meaningless question to them. Anti-realists view the realist's quest for this hidden, underlying reality as a fanatic, almost religious belief. To them, it has absolutely no place in strict empirical science. Section 3. The Map of Madness. But realists just couldn't let it go. Since they couldn't observe the quantum realm directly, they decided to invent entirely new stories to explain it. And this has created what we can call a map of madness, a constantly growing web of completely different interpretations of reality. Brilliant minds have spent almost a century basically making up new versions of reality to explain what's happening behind the scenes. And here's the real kicker. Because they're all based on the exact same underlying math, they all predict the exact same empirical data. There is literally no way to definitively prove one true or false in a lab. Now, what's really interesting about this concept is looking at the sheer mess of these interpretations. You've got different mathematical frameworks like standard quantum mechanics or Bohmian mechanics, paired up with these bizarre ontological interpretations just pasted onto them to explain reality. For example, to make standard quantum mechanics work logically, some scientists say, oh, we must exist in a multiverse. That's the many worlds interpretation. Or to make Bohmian mechanics work, others argue for invisible, universe-spanning pilot waves. This builds into this impossible, multi-layered problem called underdetermination. When a realist tries to pinpoint the true reality, they have to subjectively guess at 3 separate levels. First, theoretical underdetermination, choosing which math model to use. Second, ontological underdetermination, choosing which bizarre narrative like many worlds explains that math. And third, metaphysical underdetermination, choosing the ultimate philosophical system behind the whole shebang. Because science cannot experimentally prove a single one of these choices, scientists actually have to rely on something incredibly unscientific: personal taste. Yeah, really. Durr and Lazarevici actually admit that physicists must resort to criteria like beauty, simplicity, and explanatory power. Stop and think about the absurdity of that for a second. The most profound scientific choices regarding the fundamental nature of our universe are literally being made based on subjective aesthetics. It's almost like judging an art contest. If we're just picking our favorite version of reality based on what we think is pretty, are we even doing science anymore? Section 4. The Death of Realism. Faced with this massive map of madness, the anti-realists proposed a radical solution, which you'll find in frameworks like neo-Pyrrhonism and constructive empiricism. Their solution? Just accept all of these conflicting stories. Completely abandon the pursuit of one true reality. Instead, treat things like the many worlds theory simply as useful fictions. They argue, let's keep creating new interpretations, not because they're actually true, but just because they help us imagine how the world could possibly be. So the crucial point is captured beautifully here by Arthur Fine. Realism is dead, certified, finally. Science has essentially thrown in the towel on proving a singular objective reality. As Fine notes, the last two generations of physical scientists have managed to do wildly successful science while turning their backs on realism completely. The math works, the technology gets built, but the underlying truth of the universe abandoned. Now you might be wondering, okay, this is a fascinating puzzle, but who really cares if scientists can't picture a microscopic electron?
Section 5. Why this matters today.
Well, the source paper warns us to look at other unobservable scientific entities. Quantum wave functions aren't the only invisible things scientists ask us to believe in. What about heat-trapping greenhouse gases driving climate change? What about microscopic viruses during a global pandemic? What about complex anthropogenic climate systems? These are all unobservable entities, but they have massive, literal life or death stakes for humanity. And here is the absolute stark warning from the authors. If we allow the scientific establishment to declare that unobservable things are just useful fictions, we risk blurring the line entirely between mythical stories and scientific representation. If a quantum particle is just a made-up story that scientists use because it's handy, then what's to stop the public from viewing a deadly virus or greenhouse gases as just another made-up story? We completely lose the foundation required to trust science on global crises. Which leaves us with this final chilling question to ponder. If the stories scientists tell us are only narratives, why should we expect our societies to take seriously what scientists tell us about the world? If realism is dead, we fling the door wide open to science denialism. And that is exactly why the quantum crisis isn't just about math, it is about the survival of truth itself. Thank you for joining me for this explainer. I really hope it shifted how you view the science we rely on every single day.